Researchers searching for life on different planets often discuss the Goldilocks zone. Not excessively hot or cold, but just right. Now, NASA has found a planet that fits squarely in that zone. This is a game changer because astronomers have hit the jackpot. This discovery is their dream come true, marking a new chapter in cosmology. We have finally found the closest planet that looks remarkably similar to Earth. Astronomers believe they have found compelling evidence of what could be an Earth 2.0. This artist's rendering shows the rocky planet, named Proxima b, orbiting the Proxima Centauri star. Proxima Centauri is the closest star to our planet, apart from the Sun, and is about 4.25 light-years away. To put that into perspective, that's 24 trillion miles. A vast distance, but in space terms, it's practically our neighbor. Proxima b, the planet discovered orbiting this star, has researchers thrilled because it is the closest known exoplanet outside our solar system. Slightly larger than Earth, Proxima b orbits a star much cooler than our Sun but lies within the perfect zone for liquid water to exist on its surface. This means, in theory, it could support life. NASA has also found another super-Earth that may have conditions to support life. This exoplanet is 137 light-years away, or about 800 trillion miles. Astronomers estimate it to be about 1.5 times the size of Earth, orbiting a small, cooler reddish star. The James Webb Space Telescope has barely begun its operations, yet it has already transformed our understanding of the universe. It has delivered the clearest images of Proxima b, revealing breathtaking rocky terrains, hints of liquid water, and perhaps even traces of something beyond our comprehension. These new images give us insights into this nearby super-Earth, just 4 light-years away. What we're seeing might change everything, and it's only the beginning. Life on Proxima Centauri is a fascinating possibility, but its star is a red dwarf, known for its unpredictability. Proxima Centauri is a flare star, meaning it emits sudden bursts of energy that could severely disrupt life on its planets. Whether Proxima b can remain habitable under these conditions remains a topic of debate. Proxima b isn't alone either. It has a sibling, Proxima Centauri c, orbiting farther away. This planet was recently discovered by analyzing old Hubble data. There might even be a third planet, Proxima Centauri d, hiding nearby. The Proxima Centauri system keeps surprising us, and who knows what we'll uncover next. Rings, moons, or even signs of life may be waiting. The James Webb Telescope is not just taking stunning images, it's uncovering details we could only dream of, like frozen gases, potential atmospheres, and traces of activity on Proxima b's surface. Even nearby red dwarfs surrounded by dust, potentially forming new planets, are coming into focus. We're only scratching the surface when it comes to understanding exoplanets. Maybe one day we'll point a telescope at Proxima b and find concrete signs of life, or even civilizations. Traveling to Proxima b is a challenge of its own. With current technology, reaching even our nearest stellar neighbor would take human lifetimes. For instance, Voyager, traveling at 38,000 miles per hour, would take over 200,000 years to get there. Innovative ideas like solar sails, which use light pressure to propel spacecraft, could cut the travel time to decades, but such technologies are still in development. Projects like Breakthrough Starshot aim to send tiny lightweight probes to Alpha Centauri at a significant fraction of the speed of light. These probes, powered by high-powered lasers, could make the journey in about 20 years. While they won't carry humans, they could send back valuable data and images, giving us our first close-up look at another star system. As for Proxima b itself, its conditions are extreme. One intriguing possibility is tidal locking, where one side of the planet always faces its star while the other remains in perpetual darkness. This creates a range of conditions, with one side scorching hot, the other freezing cold, and a twilight zone in between where temperatures might be just right for life. Exploring Proxima b forces us to innovate. For instance, the idea of installing solar panels along its terminator line, the boundary between day and night, could maximize energy collection. Proxima Centauri's flares make energy storage even more crucial, pushing us to develop batteries and technologies that can handle extreme fluctuations. Solving these challenges could revolutionize how we use renewable energy here on Earth. Though human travel to Proxima b is not happening anytime soon, thinking about it inspires groundbreaking advancements. With each discovery, the James Webb Space Telescope and other observatories bring us closer to answering the age-old question: are we alone in the universe? Whether Proxima b turns out to be just another rock or the key to finding life beyond Earth, the journey to uncover its secrets has only just begun. The Proxima Centauri system holds promise, not just as a potential harbor for life, but as a proving ground for humanity's technological advancements. Exploring it could teach us how to adapt to extreme conditions, harness energy efficiently, and develop sustainable life support systems. These lessons would be invaluable, not just for interstellar travel but for improving life on Earth. Proxima b's unique environment pushes the boundaries of what we know about habitable zones. The possibility of tidal locking, with one hemisphere perpetually facing the star, could lead to extreme weather patterns. Researchers hypothesize that strong winds might circulate between the hot and cold zones, creating regions of relative stability. These areas, potentially rich with resources like water, could serve as prime locations for future exploration. But the challenges posed by Proxima Centauri's flare activity are immense. These flares could strip away a planet's atmosphere, leaving it barren and hostile. Yet, if Proxima b has managed to retain an atmosphere, it would be a remarkable feat, possibly aided by magnetic fields or geological activity. Understanding how such an atmosphere persists could offer clues about the resilience of life in harsh environments. Technological advancements like those employed by the James Webb Space Telescope continue to refine our understanding of these distant worlds. By analyzing the light from Proxima Centauri and its planets, scientists can detect the chemical signatures of water, carbon dioxide, methane, and other elements essential for life. These spectral analyses could reveal whether Proxima b has an atmosphere or even biosignatures, chemical hints of life. Looking beyond Proxima b, the Proxima Centauri system raises broader questions about the prevalence of Earth-like planets in the galaxy. If such a promising candidate exists so close to our solar system, how many more might lie hidden among the billions of stars in the Milky Way? The discovery of Proxima b could be just the beginning, spurring new missions to identify and study exoplanets. In the long term, humanity's fascination with Proxima b might lead to the development of interstellar propulsion systems, capable of carrying humans or probes to distant star systems. Concepts like fusion-powered rockets or antimatter propulsion, once relegated to science fiction, are gaining attention as feasible technologies. These breakthroughs could eventually enable humanity to reach and explore Proxima b firsthand. As we stand on the cusp of interstellar exploration, the discovery of Proxima b is a reminder of the vastness of the universe and the endless possibilities it holds. Whether or not life exists on this distant world, its study will undoubtedly bring us closer to understanding our place in the cosmos. The journey to Proxima b and beyond is not just about finding another Earth. It's about pushing the boundaries of human knowledge and imagination. The universe awaits, filled with mysteries yet to be uncovered. Each new discovery, like Proxima b, serves as a beacon of hope, guiding humanity toward a future where the stars are within reach. The story of Proxima b is still being written, and with each chapter, we take one step closer to unraveling the secrets of the cosmos. Imaginative with energy tech, we really want a method to travel for light years without conventional fuel. Enter solar sails, those massive reflective sheets that use light particles to travel through space. It's like catching the wind, except the wind is made of sunlight. Not only could these sails get a spacecraft moving without using tons of fuel, but they could also gather energy along the way. Imagine driving a spaceship simply by cruising through starlight. Pretty science fiction, but maybe possible. And what about resources on this planet? We have no evidence yet, but it's possible there are valuable minerals there. Maybe something that could revolutionize energy tech like rare isotopes or superconducting materials. Of course, even if we found something incredible, there's an ethical question here. Do we really want to start mining other planets? Space isn't exactly the Wild West, and we need to think carefully about how we handle exploration and resource use. The last thing we need is an interstellar land grab. Exploring how to reach Proxima b pushes us to rethink how we use energy here on Earth. Extreme energy tech from Proxima b to Earth could change everything. One big idea inspired by this planet is fusion energy. The extraordinary flares and all the energy zooming around between Proxima Centauri and its planet give us a chance to learn more about plasma physics. If we could harness that kind of power here on Earth, fusion could become a reality. Clean, almost limitless energy that doesn't rely on fossil fuels. It's the ultimate dream for energy scientists, and studying extreme places like this planet could bring us one step closer to making it happen. The technology we'd need for this planet could also transform things here on Earth. Imagine power systems that keep working no matter how extreme the conditions get. That's something that could benefit everything from airplanes to telecommunications. Better batteries and thermal management systems could make our power grids more resilient, even during extreme weather. Autonomous energy networks designed to operate without human intervention could help bring electricity to remote places that don't currently have reliable access. If we're serious about going to places like Mars or returning to the Moon, solving energy challenges on this planet is part of the puzzle. We need systems that can generate their own power, use local resources, and keep working long-term. This planet is like a testing ground for those ideas. From small nuclear reactors to technology that turns local rock or ice into fuel or electricity. The James Webb Telescope is helping us gather the data we need to make that possible, showing us what conditions are really like out there. This planet isn't just some distant world. It's a symbol of what's possible when we push the limits of what we know. The James Webb Space Telescope is giving us a glimpse of a place that is harsh, unpredictable, and full of challenges. But that's exactly what makes it worth studying. The lessons we learn from this planet could revolutionize how we use energy here on Earth, make future space missions possible, and help us build a more connected, sustainable world. Who knew that a rocky, flare-blasted exoplanet could become one of our greatest teachers? To really understand what's happening on this planet, we need to dive into even more details. For one, the star Proxima Centauri has a habit of blasting this planet with flares that are over 100 times more intense than the flares our Sun produces. These blasts are full of ultraviolet and X-ray radiation. On Earth, our magnetic field and atmosphere protect us from harmful radiation, but on this planet, the situation could be completely different. If it doesn't have a magnetic field, or if it has only a weak one, the constant radiation from its star could strip away its atmosphere, making it a challenge for any potential life to survive. This brings us to an interesting concept. If this planet still has any atmosphere left, it's not like the air we breathe. James Webb's data will give us the chance to learn exactly what's happening there. We could discover a mix of gases that might tell us if the planet once had a thick, Earth-like atmosphere or if it's been reduced to a thin, hostile shell. This kind of information could help us understand how planets evolve around stars like Proxima Centauri and how harsh stellar conditions shape their atmospheres over time. The idea of the habitable zone is always intriguing. This planet lies in that special region around Proxima Centauri where temperatures could allow liquid water to exist if all other conditions are right. The habitable zone is sometimes called the Goldilocks zone because it's neither too hot nor too cold, theoretically making it just right for life. But with Proxima Centauri's constant flares, it's more complicated. Even if water could exist, those intense radiation storms could make it tough for anything more complex than simple microbes to survive. Yet, this doesn't mean it's impossible. There could be some surface pockets of water that stay shielded from radiation, or perhaps a thick atmosphere could provide some protection. When we think about what energy solutions could work on this planet, the first thing that comes to mind is resilience. Any technology designed for this planet would need to adapt to wildly changing conditions. Solar panels, for instance, would need to handle variability in light levels as well as the massive bursts of radiation that come with stellar flares. This could mean building photovoltaic systems with advanced shielding or materials that can self-repair after radiation damage.